Sketch the graph that satisfies these conditions. The first condition is the vertical asymptote. At x equal to -1 from the left, the function increases without bound. And so we have an x equals -1 as a vertical asymptote. The second condition also states that there is a vertical asymptote at x equals -1, but at x equal to -1 from the right-hand side, the function decreases without bound, -infinity. There is another vertical asymptote at x equals 3. The function increases without bound at x approaches 3 from both sides. And there is a horizontal asymptote at y equal 2 because the end behavior at x equal to infinity of the function f of x equal 2. And lastly, the graph needs to pass through the origin, the point 0, 0. After analyzing the problem, we know that there is a vertical asymptote at x equals -1. So we would go in there and put in the vertical asymptote using the dot dot or dashed line. There is another vertical asymptote at x equals 3. And there is a horizontal asymptote at y equals 2. And so the vertical asymptote will guide us to sketch the graph. Now, at x equal to -1 from the left-hand side, the function increases, and so we need to sketch the graph so that as we go from the left-hand side, the graph would go up, increases, and the graph of the function would decreases at x equal to -1 from the right-hand side. And so potentially on the left-hand side of -1, we would need to shoot up. And on the right-hand side of -1, we would need to go all the way down. As x equal to 3 from both sides, the function increases without bound. And so on the left-hand side of x equals 3, we would need to go up the same as on the right-hand side of x equals 3. Now, armed with these directions and the fact that the curve needs to pass through the point 0, 0, the graph is not unique. There are many ways to sketch the graph that satisfy these conditions, and so we are going to just simply sketch one. Just make sure that whatever we sketch, all of these conditions are met. Now, we can cross the horizontal axis, but we cannot cross the vertical axis. One of the candidates for the graph looks something like this. Let's double check. At x equal to -1 from the left-hand side, the limit is positive infinity. At x equal to -1 from the right-hand side, the limit is negative infinity. At x equal to 3 from both sides, the limit is positive infinity. And at x equal to positive infinity, the function stays close to y equals 2. It cannot go back up. And also this function, it passes through the point 0, 0.